Hey guys, welcome back. Okay, so for this video, we're going to practice order of operations like we did in class. And order of operations, refreshing your memory, are these PEMDAS. Remember that? Remember in my class, I called it please excuse my dirty ass socks instead of please excuse my dear Aunt Sally. I think it's a better way to memorize it. So hopefully that gives you a little bit of a laugh. And we took a look at questions that look like this. Not too bad, you know, a little easier versions. And then we progressively got harder, like these examples. Or even these examples with brackets, even more difficult examples with brackets. And then lastly, though I didn't get to it in class, I had some that I pulled from the GED book and some other ones that I created. I didn't get to these in the class, but I may do a few on these video. And if I don't end up doing them on this video ends up being too long, you'll certainly see them next week during class. So we're going to go ahead and get started. Oh, but first, I did a warm-up in class before we even jumped into order of operations, and that warm-up covered rounding some decimal place values, evaluating some integer property operations, and then just a little bit of hint of adding, subtracting, multiplying, dividing decimals, kind of get that memory jogging. So I'm going to actually complete this entire warm-up on video right now, and then we'll go ahead and jump into the order of operation sheets that I was just showing you. Please don't forget, if you're watching this video and you're in my class, all your classwork is inside our Google Classroom here underneath the classwork tab. You'll see everything that we have here, what we did last week, what we covered this week. Like I said, order of operations is where we are. All the sheets that you see on the screen are right there for you. And by the time you're seeing this video, the video little icon will pop up right here for you too. All right, so let's go ahead and get back and get started with this warm-up. All right, here we go. So looking at the first question right here, and we say round each to the place indicated. All right, so remember what we're going to do. Again, it would also be very handy if you have the place value chart memorized. Remember, numbers before the decimal: ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions. There you go. Ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions. After the decimal, tenths, hundredths, thousandths, 10,000s, hundreds, thousands, millions. So let's go ahead and put that into practice with this first one. My first one is asking me what is the rounding the place value with this one, and the 8 is underlined. So we're going to ask ourselves, what place value is that 8? Notice it's not a decimal number. So if it's not a decimal number, you don't see a decimal, but remember there's always an invisible decimal right here, so you can start counting. 1, 2, 3, 4, 5, 6, 7 places. You see that? And we're looking at our chart. There's decimal. 1, 2, 3, 4, 5, 6, 7 places. That's in the 1 millionth. And so that's where I'll be rounding to, right? And so remember, it's going to be the number that's beside it. It's the number that's beside that underlined number that tells that number what to do. That number is 6. Remember the rule, 5 and above. If the number is 5 or above, that number is going to tell the other number to round up. So that 6 is telling 8, hey, you need to round up. Okay, so that 8 is what turns into a 9. Don't forget, it's in the millionth place. So therefore, I need enough digits to represent millions. And that millionth is going to be 6 zeros. So there we go, 9 million. So, again, we take a look at what our underlined number is. Our underlined number is 8. We know that that is in the ones, tens, hundreds, thousands, 10,000s, 100,000s, millions place. It is the 6 that tells the 8 what to do. That 6 is bigger than 5, so it's telling the 8, round up. And I'm going to round up and putting as many digits as I need to represent the millionth place. So our answer, 9 million. Let's take a look at the second one over here. 1 is underlined. It's this one that's going to tell it what to do. What place value is that one that's underlined? Look, there's it's a whole number again, so we're going to pretend a decimal's right there. So that's in the ones, tens, hundreds place. Okay, so I'm going to round. Remember with our rounding rule, it is the number that's beside it that's going to tell it what to do. That 1 is not bigger than 5. So what this one is telling this one to do is to stay the same, or round off, I would like to say. So I'm going to have 8, 0, 3, 1, okay, 0, 0. Round it off. Not bigger than 5. Taking a look at our next one over here. Here we go. All right. Now, we can tell the 5 is telling that 9 to round up. How do we round up 9? Now I'm writing it up, we'll go to 10. Yep, we know that, right? But we're not going to actually write 10 and keep dropping everything off. No, we kind of have to do a carryover thing, don't we? So that 9 is supposed to round up to 10, which means that 9 is actually going to bump up the 5 to represent that extra 10 that we need. So that is going to round up to 26. 0, 0, 0, 0, 0, 0. Going over to the next one. All right, look at our place value. Look, we have a decimal here. We have a decimal here. So tenths, hundreds, thousands, 10,000s. That's in a hundreds, thousands place. Okay. So we're taking a look at the 4, but it's that 9 that's going to tell the 4 what to do. That 9 is bigger than 5, so we are going to round up. We're going to round up to the hundreds, thousands place. Here we go. So that means I'm going 44.5. 4, 4, 3. That 9 is telling the 4 to round up to 5. Everything else I can drop off. All right, let's go over to the next row. Here we go again. This time I'm looking at the 6. The 8 is going to tell the 6 what to do. Okay. So that 8 is going to tell that 6 to round up to 7. That 6 is in the tens, hundreds, thousands place, right? So 23.037. I can drop off the 8. Again, why am I dropping off these the extra numbers? Because I'm being asked to round to whatever place value that is. That is 3 places after the decimal. 1, 2, 3. That means I'm going to have to keep 3 places in my answer in order to have a very correct answer. Tens, hundreds, thousands, tens, hundreds, thousands. I don't need to put a 0 at the end. Just making sure I match an amount of numbers that I'm rounding. Let's try it again. Like look at number, this next one right here, 74.91. I have my 9 underlined, right? So that means my answer should have 2 numbers before the decimal, 1 number after, technically, because it's rounding to the tens place. We see that as a tens place, right? So we know that the 1 is going to tell the 9 what to do with this one. That 9, we know, should round up to 10, which basically means that's going to make the 4 jump to a 5. So 75.0. Now, I know what you're thinking. Well, isn't 75 the same as 75.0? Yes, it is. Yes, it is, because we think of it just like money. But simply because this sheet is asking me to round to the tens place, I'm going to make sure that I represent the place value there. So instead of just putting 75, 75.0 represents that 0 in the tens place. We had a discussion about this in class. If you still have questions about it, let me know. Let's take a look at the next one. Our next one says the tens place. Which number is asking us? Which number's in the tens place? And then we're going to round, right? I'm looking at the tenths place. That's the 9. It's the 7 that's going to tell that 9 to jump up. That 9 needs to jump up to 10. So really that 9 is going to do what to the 6? That's right. Jump it up to 7. Now 7, right? It says the tens place again. So I'm going to make sure my tens place is represented by putting a 0. Because the tens place is 1 digit after the decimal. Yes, we're staying the same thing again here. 7, like $7, is the same thing as 7.0. But if I'm representing a rounding to a tens place, I'm going to make sure that I show, yes, that I rounded to the tens place by making sure that there's a tens place in my answer instead of just putting the whole number. Taking a look at the next one, millions. Okay, which number is in the millions place? Oh, again, that's when it helps to have this chart memorized, doesn't it? Alrighty. I know the millions place is going to be 6 zeros in a number like this. So here's your decimal, right? 1, 2, 3, 4, 5, 6, and a number, I'm in the millions place, right? So if I take a look at it that way, I know I can count off 1, 2, 3, 4, 5, 6, right? And then the millions place. That first 1 is in the millions place, okay? If you memorized each place value by name, you're saying to yourself, ones, tens, hundreds, thousands, 10,000s, 100,000s, 1 million. But it's this one that's telling this one what to do. That 1 is not bigger than 5, so it's telling that first one, hey, stay the same, round off. So 21 27, 271, I should say, and then I'm dropping off rounding because it should stay the same because the one that's circled is not larger than 5. And I'm representing the millionths place. There we go. All right. So remember, if you need further practice with doing rounding, you can go back into the Google Classroom and look underneath 913, our first practice with rounding, and you have a whole bunch of rounding place value practice here, and the video that goes along with it, about an hour worth of rounding practice if you need to take a look at that and get some more practice with it. Also, you can hit me up if you have any questions, and I'll always be right there for you. Okay, so what's next? Last week, what we did in class, we were practicing our integer rules without the calculator. Remember, you got to know those integer rules by memory, not just knowing how to do it in calculator. You got to understand how they work. It is like the base of algebra. Okay, so here we go. Next thing that we practice for our warm-up is integer rules. And remember, we began integer rules at our last class. So if you need to take another look at a deeper look for integer rules in the Google Classroom, underneath 913th, along with the rounding practice, we did the integer rule, and there's a nice video going through some of the integer rule properties and how to solve, easier questions with integers, adding, subtracting, multiplying, dividing. And also you will find the integer rule notes that I made for you. So what we're doing is putting into effect adding integers, how to subtract integers, multiplying and dividing integers without having to use a number line. So these are the rules to help things go easier. Again, something you completely need to have memorized in order to understand the basis of algebra. Again, the first half of your GED test are questions without the calculator. So you can't rely on a calculator doing the integer rules for you because you won't be able to use a calculator if you get some of these type of problems on the first half of your test. Let's take a look at the first one. All right, I'm going to rewrite it. So what I have is 7 plus -3 plus, that's -5 minus 10. Here we go. All right. So I'm going to start from left to right. These are all adding or subtracting. Don't confuse these questions with order of operations. These are just basic integer practice. They just look a little lengthy, okay? So order of operations, what we're going to practice after this warm-up, right? Those questions look more like this or like these. What I'm asking here are just practicing your integer rules. So I want you to start everything from left to right, So we're going to start with these two first, all right? I have 7 plus a -3. What's the rule? I have a positive number plus a negative number. Again, going back to our rules with adding. Anytime we have a positive plus a negative, we have our positive plus positive rule, our negative plus negative rule, our negative plus a positive, or positive plus negative. So this is the rule we're looking at. What do? We're first going to subtract to find the difference between the two numbers. Okay. So I'm going to subtract to find the difference between the two numbers. So I have a 7 and a 3. What's the difference between 7 and a 3? That's 5, isn't it? 5, 6, 7, 4. 4, 5, 6, 7. So we have a 4. Okay. Now, is it going to be positive or -4? Take a look at your rules. What does it say? The rules say, once I subtract to find the difference between the two, I then keep the sign of the larger digit. All right. So what digit is larger? That 7 or the 3? That 7 is larger. That 7 happens to be positive, so I will keep it as a positive 4. Let me go ahead and bring down the rest. I have this. There we go. Next, I'm going to take a look at this part. All right. Now that's 5 plus, or excuse me, a positive 4 plus a -5. Again, you have a positive plus negative. What do we do when we have a positive plus negative? Step 1, we subtract to find the difference between the two. What's the difference between 4 and 5? Subtract. Now, when you subtract, you don't have to try to do that in your head. You can put it the other way around and do that. Okay? We can see that the difference would be 1. All right. So again, you're just trying to find the difference between those two numbers. The difference is 1. Keep the sign of the larger digit. What's a larger digit? This 4 or that 5? Remember, when I say the word digit, I'm not saying the word number. Okay? Digit is a visual representation I'll say, of a number, a digital representation of a number. So when I say digit, that means you're either just looking at the 5 or you're looking at just the 4, not actual sign. So if I keep the sign of the larger digit, which digit is larger to 5? And then that tells me I'm going to keep the sign of the larger digit. That 5 happens to be negative. So my answer is -1. Reason why I keep explaining the difference between digit and a number. Again, a digit is just a visual representation of a number. If I say keep the sign of the larger number, think about it. What number is larger, 4 or -5? 4 is larger. But I know a positive one is not the correct answer. Therefore, if I say keep the sign of the larger digit, I'm looking at a 5, not the negative part, just the 5, and the 4. Which one's the larger digit? 5. And keep the sign of the larger digit. That sign happens to be a negative, so -1. And I know I keep explaining that in my video, so hopefully you become more and more comfortable with it. I hear lots and lots of teachers say, keep the sign of the higher number. That's not right, because the higher number is actually 4, not -5. What you want to do is keep the sign of the larger digit. Let's continue. All right. So if I bring down the rest, I have a -10. This is a subtraction problem. Remember, think everything as subtraction. What do we do with our subtraction rules? I have a -1 -10. Go back, look at your subtraction rules. Step 1, change the sign, change the problem to addition. Okay, if I change it to addition, it's going to be this. Step 2, change the sign of the second number. Look at what I have. My second number is a +10. So if I change the sign, it now becomes -10. Step 3, follow the addition rules. Okay. I have a -1. That negative's there, remember. -1 plus a +10. A negative plus a negative. What do I do when I have a negative plus a negative? Go to your addition rules. Negative plus negative rule right here. Negative plus negative. My answer is negative. I'm just going to add them together. For example, -5 plus -8 gives me -13. And remember, in class, I like to call that ghetto shopping, because you have no money. And then you spend even more money, which means you owe the bank even more money. Anytime you have a negative plus a negative, you should not be in the positive. So if I add them together, I have 11, keeping it negative. So my answer for the first one right there, -11. Let's take a look at the next one. All right, this time I'll put it right here. All right, I'm going to put the next one right here. It says -14 minus -6 plus 18. Start with the first two. We have this. You have a subtraction problem. -14 minus 6, right? Minus -6, excuse me. So remember the rules of subtraction, right? We have, there it is. Step 1, change it to addition. All right, we're going to go back, change it to addition. Bam. Step 2, change the sign of the second number. If I have a -6, it now becomes +6. There we go. And last step, step 3, follow your addition rules. Okay. I have a negative plus a positive, -14 plus a +6. I'm going to subtract to find the difference between the two. Remember, first thing you need to do is subtract, find the difference between the two, and that will be 8. After we subtract, keep the sign of the larger digit. What digit is larger, the 14 or the 6? The 14. That 14 happens to be negative, so therefore my answer will be -8. Now I'm going to bring down the rest. Here we go. It's already an addition problem. Look again, I have a negative plus a positive. What do I do when I have a negative plus a positive? I'm going to subtract. Keep the sign of the larger digit. Which digit is larger, that 8 or that 18? The 18. So my answer will stay a +10. All right, taking a look at our next one. We write it over here. I have 12 times -2 divided by a -2. All right, let's remember, anytime we see a set of parentheses and they're right next to each other like this, that means multiply. So I'm multiplying 12 times a -2. What is the rule when we have a positive times a negative? Taking a look at our rules, look at this, multiplication rules. Positive times positive, answer will be positive. Negative times negative, your answer still will be positive. Negative times a positive, or positive times a negative, that's when you have a negative answer. Same thing apply for the dividing rules. So again, in this case, I have a positive times a negative. Positive times a negative, I multiply them together, I'm going to get 24, and my answer will be negative. Let's bring down the rest. So now I have negative 24 divided by negative 2. Again, those rules, multiplication and division, are the same. So I could say positive divided by a positive, my answer is going to be positive. Negative divided by a negative, my answer is positive. Only when I'm mixing them, negative divided by a positive or positive divided by a negative, will my answer be negative. And that's what I have here is actually negative divided by a negative, right? Go back, take a look. Negative divided by a negative, your answer will be positive. So 24 divided by 2, that's going to give me 12. And remember, a negative divided by a negative, answer is going to be positive. So that one, our answer is positive 12. Moving on to the next, take a look at what we have. This time I have 6, rewrite it over here, 6 times 5 divided by negative 3 times 2. Okay, so what do we do here? First of all, you notice it just looks like a weird fraction, right? Fractions mean division. Fractions mean division. In all my videos, you'll hear me say that whenever we're looking at something that's a fraction, I'm always going to remind you that fractions mean divide. So we're going to divide the numerator and denominator. But before we can do that, we have to reduce what's up here first and reduce what's down there. That means I have to solve the top half, solve the bottom half, and then divide those two numbers. Let's take a look at the top half. My top half, I have a regular 6 times 5, right? 6 times 5, that's going to give me 30. Now down here, I have negative 3 times 6. That's going to give me negative 3 times 2 is going to give me negative 6. Here. Now we're going to reduce, which means you're going to divide. And what I mean that is, I'm actually doing this. Now I know my answer is going to be negative because look, I have a positive divided by a negative. So whatever my answer is negative. And then I look at it this way. I can see that 6 will go into 30. That's 5 times, right? So answer will be negative 5. So again, when it comes to the fraction part, and you got this, you're going to reduce that fraction. Basically, you're going to divide that fraction. And when you're dividing the fraction, that bottom number is on the outside of your division sign, and then the top number is on the inside. And you can look at it this way and realize you have a division problem. Okay? There we go. Knowing the answer is going to be negative 5 because of that rule, a positive divided by a negative. Again, how we got to negative 5. Let's keep it going, and you can see the other ones in practice. Let's take a look at this one. Next, I have negative 23 plus negative 11 minus negative 15 plus 21. Make sure I wrote that right. Negative 23 plus negative 11 minus negative 15 plus 21. Okay, I'm starting on the left side with these two. I have negative 23 plus negative 11. Again, what is the rule when we have a negative plus a negative? We're going to keep it negative and just add them together. So the 23 plus 11, that's going to give me 34. Keeping it a negative 34 because a negative plus a negative. Addition rules. Negative plus a negative. Answer is negative. Just add. So now I have negative 34. If I bring down the rest, now I have this. So I'm going to go here. We have a subtraction problem. Look at this subtraction problem. Okay. We have negative 34 minus negative 15. Step 1, subtraction. Change it to addition. Step 2, change the sign of your second number. That's a negative 15. I'm going to change it to positive 15. And then step 3, follow your addition rules. I have a negative 34 plus 15. Negative 34 plus 15. Of course, I'm going to subtract. Keep the sign of the larger digit, which would make this negative. Because remember, with a negative and a positive, you subtract to find the difference. Keep the sign of the larger digit. So my answer for that so far is negative 19. Okay. Now, we did see a little bit of a shortcut. And remember, I talked about that shortcut in class. That combination that we had of the negative 30, excuse me. Remember, it was originally negative 34 minus negative 15, right? So with the negative 34 minus 15, and I had first did step 1, change to addition, step 2, change the sign of the second number, and then follow the subtraction rules. But remember the little shortcut or the hack that I called it in my last video. Anytime you see this combination of a subtraction, half the parentheses, a negative sign, it creates a plus sign. So now you can simply just look at it as negative 34 plus 15. That gives us negative 19. So either following the steps all the way through, but when you see that little combination right there, look at it and think a plus sign. Let me go back over to our other problem, and I'm going to bring down a rest. I have 21. So now I have negative 19 plus 21. So negative 19 plus the 21, I'm going to follow my rules. I'm going to get a 2. There we go. Negative plus positive, remember, subtract, keep the sign of the larger digit. Our final answer being 2. Let's keep it going. All right, so this time, negative 3 times negative 5 times 2 times negative 10. Negative 3 times negative 5 times 2 times negative 10. Start over here. Negative 3 times, got the other side of the parentheses, there it goes. Negative 3 times negative 5. Negative times negative is a positive. 3 times 5 is 15, so positive 15. If I bring down the rest, I have this. Now I'm going to go here. 15 times 2, positive times positive. I'm going to keep positive, multiplying my two numbers together. And then I have this. I have negative 30 times negative 10. 30 times negative 10, that's going to give me negative 300. Positive times a negative. Answer will be negative, just multiply. Trying the next one. This time I have 4 times negative 4 divided by negative 8 times negative 2. Do the top first. 4 times negative 4. Positive times negative. My answer is negative. Just multiply them together. 4 times 4, 16. At the bottom, negative 8 times negative 2. Negative times a negative, my answer is going to be positive. Just multiply them together. 8 times 2, that is also 16. Then I divide. 16 divided by negative 16, or this 16, negative 16 divided by 16. You know your answer is going to be negative. How many times will it go in? 1. Final answer here, negative 1. And keeping it going, our next one over. This time I have 3 times negative 4 times 2 times 5 divided by negative 6. Let's work out that top part. I'm going to bring it over here. 3 times negative 4 times 2 times 5. Starting with the first 2, we see this. Negative times positive, my answer is going to be negative. Just multiplying. I get 12. 3 times negative 4. Multiply it with the 2. Negative 12 times a positive 2 is negative 24. And then I'm going to multiply it with a positive 5. So negative 24 times a positive 5. 24 times the 5, that's going to give me 120. But that's going to be negative 120. So far I have a negative 120 up here. So that's what all of this is equaling right here. Negative 120. Now remember, all this multiplication, like this multiplication, all of that you should be doing by hand. Okay? And then I'm still going to divide that by a negative 6. So I'm going to divide that by a negative 6. My answer will be 20. And it's going to stay a positive 20 because a negative divided by a negative, my answer is positive. Positive 20. Keeping it going. Okay, so this time I have negative 7 minus 20 minus negative 14. Start with the first two. That's a subtraction problem. Negative 7 minus 20. Let's look at that down here. Negative 7 minus 20. Subtraction problem. Remember, step 1, change it to addition. Step 2, change the sign of your second number. That second number is a positive 20. So now I change it to a negative 20. In step 3, I'm going to follow my addition rules. I have a negative plus a negative. Ghetto shopping. I'm going to add them together, keeping it negative. So all that equaled negative 27, right? Let's bring down the rest. Bring it down over here. I have this. Look at that combination. I'm going to do the hack. Subtraction, half a parentheses, negative, creates a plus sign. Follow your addition rules. Negative 27 plus 14. So I have negative 27 plus 14. My answer to this is going to be negative 13, because remember the rules. A negative plus a positive, subtract, keep the sign of the larger digit. One more of the integer practice here. This time I have 6 minus negative 3 plus negative 5 plus 8. Now again, remember, this is not order of operations. This is just integers. Okay, so we're going to start from what we see first. And what I see first is here I have 6 minus a negative 3. Again, do you see that combination? Look at that. Creates a plus sign. So I can really just look at this as 6 plus 3, and that's going to give me 9. Let me bring down the rest. I have this. So now I'll go here, positive plus negative. We're going to subtract, keep the sign of the larger digit. So we have 9. If I subtract a 5 from it, I'm going to get 4. 9 is a larger digit, so I'll keep it as a positive 4. Then I bring down the rest, and I simply see 4 plus 8. That will give you a positive 12 for that final answer. All right, so now I'm going to work these problems down here, these decimal problems. I just threw them in there as part of the warm-up. We didn't get to do them in class because I was running out of time, but I will do them here. So if you're okay with this so far, you can just go ahead and fast forward through the video and go on to the integer part. Here we go with the first one. Now, when I'm adding decimals, I'm going to first make them vertically. So I have 921.74, and I'm going to line up my decimal. My next number is 2.7. I'm going to line it up like this, 2.7. Makes adding them a lot easier. Now you see all these gaps I created? In order to make things look nice and neat, I can fill gaps in with zeros. And then I'm just going to simply bring my decimal down to where my answer will be. So when you line up the decimals like this, when you're adding, if you line them up this way, all you have to do is bring that decimal straight down and just add like you normally would. Starting on the right side, 4 plus 0, 4, right? 7 plus 7, that's 14, carry 1. And then I have 2 plus 1 plus 1, that's going to give me 4. 2 plus 0, 2. 9 plus 0, 9. There you go. Final answer, 924.44. Remember, the key is lining up those decimals and filling in any gaps as you see them. Now, there's different ways in which that you can do these. I'm just showing you a method that works best for me. For my next one, whenever I see a subtraction of decimals, you know what? I'm looking at everything as it's an integer problem. So let's look at this as if it was an integer problem of subtraction. First thing I'm going to do is step 1, change it to addition. Step 2, change the sign of your second number. So if I look at it this way, okay, I know that I'm going to follow the addition rules of a positive and plus negative. What do we do when we have a positive plus negative? We subtract to find the difference and then keep the sign of the larger digit. So if I do it this way, I can now say all I have to do is subtract those two numbers and keep the sign of the larger digit. All right, I can do that. So I'm going to find the difference between 94.9 and 41.871. I'm going to put my 94 here, 94.9. Line up your decimals. I have 41.871. And I will subtract. So when I go with my subtraction from here, first thing I'm going to do is plug in my empty spaces. There we go. All right, so here we have, we're going to subtract across some zeros. All right, so we got to watch this very carefully, okay? We know first that what our answer is, our decimal is going to be right there because it lines up. Okay, so I have the 0 minus 1. Remembering borrowing, you would make this to a 10, and this would become a 9, right? And this will become an 8 with your borrowing across 0 with subtractions. Again, let's take a look at that. Okay. You have to make this a 10. If I make this a 10, this becomes a 9. If I make that 0 into a 9, that means I need to borrow from here, making this an 8. And now let's do our regular subtraction. I have 10 minus 1, which is 9. 9 minus 7, which is 2. 8 minus 8, 0. And then I can do my regular 4 minus 1, which is 3. And then my 9 minus 4, which is 5. There we go. 53.029. And remember, what's it going to be? Positive or negative? Let's go back. Remember what we did. We changed this to an addition. We changed this to a negative. So subtract, which we did. Keep the sign of the larger digit. What digit is larger? The 94.9 or the negative 41.871? 94.9 is larger. So therefore, I will keep my answer positive. Answer for this one, 53.029. We'll have more practice of those in class because I know everyone needs that reminder, that refresher on how to do the subtraction with decimals especially. Let's take a look at one with the multiplication. So I'm going to put my multiplication one. I'm going to rewrite it up here. I have 0.94 times 9.2. Okay. Now with multiplication, I don't have to line up my decimals. In fact, I'm going to ignore my decimals for right now when we do the multiplication. For me, my method is to ignore the decimals for right now and just do regular multiplication, which of course means you have to remember how to multiply these numbers without a calculator, right? Let me start with the first set. First, let me do 4 times 2, that's 8. 9 times 2, that's 18. Carrier 1, right? 0 times 2 is 0. Plus the 1, I have 181. There we go for the first row. Now, if you remember, what we do next is place a 0 and then start multiplying with the second number. The first row of multiplication represents multiplying with the 2. My second row is going to represent when I multiply with the 9. So I'm going to first go 9 times 4, that's 36. Carry my 3. 9 times 9 is 81, plus 3, 81, 82, 83, 84. 0 times 9 is 0, plus my 8, and notice it pushes it off to the side. Now I add these two together. 8 plus 0, 8. 8 plus 6, that's 8, 9, 10, 11, 12, 13, 14. 4 plus 2, 6. And then my 8. Now I'm going to place my decimal. Where do I place my decimal? First thing I'm going to do, take a look at the first number. How many places are after that decimal? 2 places. I have 2 numbers after this decimal. I have 1 number after this decimal. Altogether, I have 3. So all the numbers that are placed after the decimals, that's 1, 2, 3. 2 numbers up here, 1 number down here. I start on this side, and that's how many times I'm going to bounce over and place my decimal, if you remember. So I'm going to bounce 3 times. 1, 2, 3. Placing my decimal right here. Therefore, leave my answer as 8.648. How to place your decimal. Do your regular multiplication. Count the number of places after the decimal in each number. This number has 2 decimal places. This number has 1 decimal places, so that's 3 altogether. I'm going to start here, and I'm going to bounce over 3 times. 1, 2, 3, and that's where the decimal would be for your final answer. Final answer, 8.648. Okay, so we're now at that last problem, which was a practice of dividing decimals. Here we go. 1.92. 1.152. Okay, here we go. Sorry about the sloppy handwriting. So when we divide decimals, if we have a decimal on the outside of the house, let's say that decimal needs to be all the way at the end. So whenever you have a decimal on the outside of your house, you have to move that decimal to the end. So if I move this decimal to the end, how many times would it take it to move? 1, 2. I would have to move it 2 places in order to get it to the end of the number. However many times I move that decimal on the outside of the house, I have to move it the same amount of times on the inside of the house. So if my decimal's right here on the inside of the house, I need to move it over 2 times. 1, 2. Therefore, putting my decimal right here. So if I rewrite it, I'm really looking at this, because I have to move my decimals. Remember, decimals on the outside of the house, if you have them, it has to be at the end before you can do any division. Okay? And so I had to move it 1, 2 times. If I had to move the decimal out here, I have to move the decimal in here that same amount of times. The decimal was right here. If I move it 2 times, 1, 2, the decimal is now right here. So therefore, this is what I'm looking at. And then all I would have to do is bring my decimal right on top of the house. So whatever my answer is, that's where the decimal is going to be in my answer. So let me rewrite that up here so I have some space. I have 192, right? And 115.2, knowing my decimal is going to be right here. Let's start working that out. Okay, here we go. Division by hand. Practice. I'm going to take it step by step. Here it is. I have 192. I know it's not going to fit in 1. I know it's not going to fit in to 11. I know it's not going to fit into 115. So how many times will that 192 fit into 1,152 is what I'm looking at. I'm not sure. I don't know about you, but I don't know how many times this is going to fit into this number. Now that I have the decimal up here, I can ignore the one right here. So let me just take it away so you can see it as a really big, large number, right? So I have 192. How many times is it going to fit into here? Okay. Well, I don't know. And if you're like me, by now you'll be doing some scrap work. I'm going to guess maybe it'll fit 5 times. So on my scrap work, I'm going to do, I wonder how many times it'll fit using 5. 5 times 2 is 10. 9 times 5 is 45, plus 1 is 46. And 1 times 5 is 5, plus 4, that would give me 9. That's 960 times. So 5 might be a little bit too small. I might be able to fit that in one more time because I'm trying to get up to this high, right? So what am I going to do? I'm going to try on my scrapwork paper side again. This time I'm going to try it with 6. See if this comes to a closer number. 2 times 6, that's going to give me 12. 9 times 6 is 54, plus 1 gives me 55. 1 times 6 is 6, plus 5, 6, 7, 8, 9, 10, 11. That gives me 11. Oh, look at that. Comes out nice and evenly, doesn't it? Look at that. Came out nice and evenly. Therefore, I know my answer is 6. Because 6 times 192 gave me the 1,152. There it is. And that's all I have to do. So my answer, leaving me with 0.6. 0.6 for our answer. So that's what I would leave. I don't have to have all those zeros in the front. I can read that as 0.6. I could write it as 0.6, or I could have kept all the zeros. Doesn't matter. All representing the same number. All right. So now it's time to get into order of operations. Here we go. So when we were in school, we remembered order of operations by using PEMDAS. When we were in school, our teacher wrote it this way. Please excuse my dear Aunt Sally. And we use that acronym. Please excuse my dear Aunt Sally. We wrote this as an acronym to remember the order of how we solve things when it comes to these types of questions. P stands for parentheses. You do what's in parentheses first. Then you do exponents. Then you multiply and divide. Then you add and subtract, right? Now, of course, I keep joking around. Like I said, I don't teach it as please excuse my dear Aunt Sally. I teach it as please excuse my dirty ass socks. I think that's much more funny when you're dealing with adults. Okay. So, but here's the thing that we get tripped up with all the time. The multiplying, dividing, and adding or subtracting. When we do this, it's multiply or divide whatever we see first from left to right, or add and subtract whatever we see first. That means addition doesn't necessarily come first. Multiplication doesn't necessarily come first. And this is why it's better to memorize PEMDAS going this way. Because it goes like this. Yes, do what's in parentheses first. Then do exponents. Then we will multiply or divide whatever we see first. Sometimes it might be division we see first in that problem, not multiplication, and that's okay. Multiply or divide whatever we see first, from left to right as the problem goes. Same thing with adding or subtracting. It's add or subtract whatever we see first when we look from left to right. Okay, so keep that in mind as we go through the process. Let's start with the first one. First one, here we go. All right, so look at what I have here. I'm going to write my PEMDAS. Okay, so I'm going to start with parentheses. Do I have anything in parentheses? No. This does not count as doing something in parentheses. This parentheses is just telling you, hey, this is a -2. Because if the parentheses weren't around this -2, it would look really weird without having that parentheses there. So this does not count as the PEMDAS parentheses, meaning do stuff that's on the inside of the parentheses first. For example, for things in which we have to do stuff on the inside of the parentheses first, it's this. See this set of parentheses and all the stuff in between it? If we had that with our first question, we would do this. This is what parentheses mean. Do everything that's on the inside of the parentheses first. The parentheses does not stand for when you're just having a parentheses surround a negative number. Okay? We'll get used to that as we go. So technically, we do not have anything in parentheses here. So check. We can move on. The next thing that we do are exponents. This is the exponent. Remember, that is not 2 times 3. That is 2 times 2 times 2. Okay? 2 times 2 is 4. Times the last 2 is 8. So far, I have 8. I'm going to bring down everything else. I'm going to do it step by step. I have this. All right. So we took care of parentheses. Check. Now we're going to multiply or divide whatever we see first. Take a look. Do we see any multiplication and division? We do. We see this multiplication problem, don't we? So that's where I'm going to go. 8 times 10. That's going to give me 80. I bring down everything else. I'm now here. Is there any other multiplication and division? There's not. There's nothing else to multiply and divide. It's either all add or subtract. So that means I'm done with this part. And now I go to what's next. Add or subtract whatever I see first. What do I see first? Adding or subtracting? I hope you say subtracting, because that's what we see first. Remember, it's add or subtract whatever we see first. And so I first see the 80 minus the 3, right? So I have my 80 minus the 3, and that's going to give me 77. I bring down my rest. I have this. Now I have 77 plus 2. And that's the last part to finish off this problem. Remember your integer rules. Positive plus negative. Positive plus negative. Subtract to find the difference. Keep the sign of the larger digit. So if I subtract 77 minus 2, that's going to give me 75. What's larger, the 77 or the 2? The 77 is larger, and that 77 is positive. So I will keep my answer as positive. For this entire one, your complete answer for this first one of order of operations is 75. Let's keep it going. Move over to the next one and practice that. All right, here we go. So again, I have my, please excuse my dirty ass socks. There we go. Check for parentheses. Do I have anything in parentheses? Now I can see it. This whole thing is in parentheses. So that's where I need to start. But where do I start when I'm in the parentheses? Even when you're in the parentheses, you still have to go in this order. So I can't do the adding or subtracting first. I have to do this first because it follows PEMDAS order. So remember, even when you're in the parentheses set, you still must go in order of PEMDAS. So don't start doing this. You have to start here because exponents comes before the adding or subtracting. So remember this. Remember, that's not 5 times 2. That's 5 times 5. That's 25. I'm going to bring down my rest. I have this. Right? Now where do I go? Now I have all adding or subtracting. I'm going to add or subtract whatever I see first. What do I see first is 25 minus 6. So I'm going to do my 25 minus 6, right? Following my integer rules, I'm going to get 19. I bring down my rest. I have this. Now I have 19 plus -5. Remember, all this you should be able to do by hand. Remember what we do when we have a positive plus a negative. We subtract, keep the sign of the larger digit. If I do that, that's going to give me a positive 14, right? Don't forget, now you're outside the parentheses and you have to bring down the rest of that problem. So it's 14 times 2. That's the last step of the problem. So I multiply those two together. I'm going to get my final answer, 28. Let's try another. Here we go. All right, let's take a look at this one. Write down my PEMDAS. Please excuse my 3S knocks. Here we go. Parentheses. Do I have anything in parentheses? I have parentheses, but those parentheses are just surrounding negative numbers, so that doesn't really count. Now let's for exponents. Do I have exponents? Yes, I do. I have this exponent. That's negative 3 three times. So I'm looking at negative 3 times negative 3 times negative 3. Negative 3 times negative 3, that's going to give me a positive 9, remember your integer rules, times another negative 3, that's going to give me negative 27. Remember your integer rules, right? And please, don't take these integer rules for advantage. You must remember them by doing them by hand. Don't just use your calculator. Make sure you understand those rules. If you don't, you're certainly going to get questions on the first 10 questions on your GD test wrong. You'll get some of those questions wrong if you don't know integer rules by heart. All right. So remember, I had gotten that was as a positive 20, it was a negative 27 so far. Now I'm going to bring around the rest. Plus 10. This minus sign is still there because the negative 27, remember, was just for this part. That means that one still has to come down. Now we're here. Okay. Exponents is done. I'm going to multiply or divide whatever I see first. What do I see first? I hope you see what I see, and that's going to be this, right? 9 times negative 10, negative 90. Remember your integer rules. Let me go ahead and bring down everything else. Look at this. I brought down everything else. Any more multiplication or division? There is not. So multiplication and division is over. Now I will add or subtract whatever I see first. What I see first in this problem is subtraction. This is the subtraction problem that I have. Because remember, that was a negative 27, right? I bet you if I put a parentheses around here now, it'll make it look a little easier for you, doesn't it? So you can see this as negative 90 minus negative 27, right? Let's work that over here by hand. Watch this. Remember, this is that integer rule taking effect. I'm going to put the parentheses around it so you can see it better as a subtraction problem. What do? Step 1, change it to addition. Step 2, change the sign of the second number. That's a negative 27, right? So now it becomes positive. In step 3, we're going to follow our addition rules. A negative plus a positive. What do we do with a negative plus a positive? We subtract. 90 minus 27, that's 63. Keep the sign of the larger digit. What's larger, that 90 or the 27? The 90. That 90 happens to be negative. So negative 63. So all that is going to equal negative 63. Hey, did you also see the shortcut by doing this? Look at that. See that combination? Negative plus positive. Subtract, keep the sign of the large digit. You're still coming up with negative 63 if you just took that little shortcut. Let's continue with the rest. Remember, I still have the plus 10 that I had to bring down from here. So now I have negative 63 plus 10. Negative plus positive, again, subtract. Keep the sign of the larger digit. Answer for that one will be a negative 53. Let's keep it going. All right, here we go over here. Practice makes perfect, right? All right, first start with parentheses. Do I have something in parentheses? Yes, I do. I have all of this right here. When we're in the parentheses, where do we start? Where do we start? Do not start with a 7 minus 4. Remember, you have to go in the same order as PEMDAS. So that means I must start with the exponent first, which is this. That's 2 times 2 times 2. 2 times 2 times 2. Remember, 4 times that last 2, that gives us 8. All right? So 2 times 2 times 2, 8. If I bring everything else down, I have plus 4 minus 7, because I'm still in that parentheses, right? Where do I go from here? Add or subtract whatever I see first. That means I'm going here. 7 minus the 4. 7 minus the 4, that's going to give me 4, 5, 6, 7. That's 3. And my plus 8, that's going to give me 11. 8, 9, 10, 11. So that was all the parentheses. Don't forget, you still have to bring everything else back down. So that's times negative 5, like this. So now where I am is negative 5 times 11, right? Negative plus positive, my answer will be negative, and then I'm going to multiply the 5 times 11. That will give me a negative 55. Final answer for that, negative 55. Keep it rolling, my friends. Practice makes perfect, right? Keep it going. Here we go with the next one. All right. Remember? PEMDAS. Here we go. There's no parentheses, but I do have an exponent right here. Look at that. So that's negative 3 times negative 3 times negative 3. Negative 3 times negative 3 times negative 3. Negative 3 times 3, positive 9, times another negative 3, remember, negative 27, right? Negative 27. So let's put that there. Did I just do this one? Oh, it looks similar because of the one that's up there. All right, let's go ahead and continue. All right, so we know that this is going to be a negative 27. All righty, so I'm going to write that negative 27, and just so that you can see it clearly, I'm going to put the parentheses up, around it. Now I'm going to bring everything else back down. There we go. So where do we go from here? So from here, we don't have any more exponents, so we will multiply or divide whatever we see first. And if we multiply or divide whatever we see first, guess what I see? I see that. So 6 times 2, that's 12. If I bring everything else back down, I have this. All right. Any more multiplication or division? Nope. So check. We're now on add or subtract, whatever we see first. And what do I see first? I see a 10 plus 12 first. Okay. That's going to give me 22. If I bring down the rest, I have this. Do you see the shortcut that I see? I hope so. There we go. And so I have 22 plus 27. Now, if you didn't see the shortcut, then you should have seen this as an integer subtraction problem. So we'll take it that way. Just in case you didn't see that quick shortcut, here's the long way that you should have done. Step 1, change it to addition. Step 2, change the sign of your second number. Negative 27 becomes positive 27. Now you can see that shortcut. 22 plus the 27, giving me total of 49. 22 plus the 47. 22 plus the 27. There you go. Let's take a look at what else. Going over to the next one. Here we go. All right. Start. Parentheses. Do I have anything in parentheses? Now, sometimes it's going to start to get a little bit difficult to figure out what's in parentheses and what isn't, but I'm hoping you see the parentheses set that I do. I see this one. Got to look very carefully. You see that? So that's where we're going to go. And what does it say inside this parentheses? It says negative 5 minus negative 2. All right? Let me just write that down here. Watch this. Negative 5 minus negative 2. Now, hopefully you started seeing the shortcut. You see that pattern in the middle? Look at that pattern. I see it. So really what I have is negative 5 plus 2. Negative 5 plus 2, that's going to give me a negative 3. Now, if you didn't see that little shortcut and you looked at it the long way around with the subtraction rules, This is what you should have done. Step 1, change it to addition. Step 2, change the sign of your second number. The second number is a -2. It now becomes a +2. Now step 3, follow your addition rules. Negative plus positive, you know you're going to subtract. Keep the sign of the larger digit. So again, you still see it as a -3. So let me put that up here. That was -3. But remember, that 2 is still there. And let's bring down everything else. There we go. So where do I go from here? I'm hoping you say the exponent. That is correct. Next thing I'm going to do is that exponent. So I'm going to do -3 times -3. That gives me a +9. I bring down everything else. I'm now here. There we go. There we go. Now where do I go? We have multiplying and dividing. Remember, we're going to multiply or divide whatever we see first. What I see first is -7 times 9. So my -7 times 9, that's going to give me -63. I'm hoping you remember your integer rules. Bring down the rest. I have divided by 9, right? -63 divided by 9 is going to give me a -7. Because remember, negative divided by a positive, right? Your answer is going to be negative. So final answer for that one, -7. Let's keep it moving. All right. Where is our parentheses set? I see the large one. You can see it right here. So that's where I'm going to start. And where am I going to start within that parentheses? I'm going to start with the exponent. I'm going to go here. -2 times -2 is 4. Now, if I bring down everything else, I still have my +5 on this side. I still have my minus and a -5. So this is where I am here. So where do I go next? I hope you realize it's here. And I have -4 or -5 minus 4. -5 minus 4. Let's do that on the side. -5 minus 4. It's a subtraction problem. Step 1, change it to addition. Step 2, change the sign of your second number. That's a +4. It's now -4. Step 3, follow your addition rules. A negative plus negative. Add, keep it negative. So this part right here, -9. But remember, you still have that +5. So that's where we are now. So -9 plus 5, remember your addition rules, subtract, keep the sign of the larger digit, right? This is going to give me -4. Woo. So far, that's everything that was in the parentheses. Don't forget to bring the rest of this back down. So I have times my -6, that's in front of it, right? So now what I have is -6 times -4. Remember, negative times negative is going to be a positive. Just multiply the two numbers. 6 times 4, 24. Answer for that one, +24. And here we go. All right. Identify your parentheses set. Now, by now, you should probably put the video on pause and work this one out yourself, and then unpause, and let's see if we come up with the same answer. All right. So I have my parentheses. I see it right here. I'm going to start with the exponent. -3 times -3 times -3. Didn't we do that before? I think we got -27 the last time that we had done that, right? So, oh, sorry, it's -3 squared. So that's just -3 times -3. That's going to be a +9. If I bring everything else down, don't forget, that's still in the front. This is where I am. Okay, so now, add or subtract whatever you see first. Step 1. Step 2. Subtract, keep the sign of the larger digit. That's -7. So -7. Bring down the rest. Plus a -5. -7 plus -5. That's going to give me -12. So that took care of everything that was in the parentheses. Don't forget, you still have this. Bring that back down. Now I have -7 times -12. 7 times 12, 84. and a negative times a negative, answer will be positive. So my answer here, positive 84. A few more for this page. Here we go. Okay. Again, put on pause. See if we come up with the same answer. I see my parentheses set is right here. Where do we start? You guessed it, that exponent. 9 times 9. 9 times 9, 81. I bring down my rest. This is where I am. Now where do I go? You see just adding or subtracting, so you're going to start from whatever you see first. If I start with what I see first, I have this. 81 minus a negative 4, right? On the side, 81 minus negative 4. Now, subtraction, so step 1, change it to addition. Step 2, change the sign of the second number. Step 3, follow your addition rules. I have a positive plus positive. I'm going to add those together, and I'm going to get a positive. 81 plus my 4, that's going to give me 85. So that's 85. Now, again, if you're used to seeing the shortcut, you would have seen this. That combination right there. And then you see it as 81 plus 4, 85. Bring down your plus 3, so add 3 more to it. I'm going to get 88. Don't forget the rest of the problem. Now you got to bring that down. I have 88 divided by a negative 8. Well, negative divided by a positive. My answer is going to be a negative. And 8 will fit into 88 11 times. So final answer here, negative 11. Last one for this page. Here we go. All right, starting with parentheses. Do I have anything in parentheses? Oh, and I don't. Remember, these parentheses are just surrounding negative numbers. There's nothing to do inside those parentheses. So that means I'm going to start with my exponent. I start with my exponent. I have this. 3 times 3 times 3. We've done it many times now. And we know that this is going to be 20. This is 3 times 3. Let me do it again. 3. That's 9. Yep, 9 times 3, 27. I had to double check on that one, as always. So that's going to give me 27. Okay. I bring down the rest. I'm here. So where do I go from here? So no more exponents. So I'm going to multiply or divide whatever I see first. And guess what I see first? I see a multiplication first, don't you? I see the multiplication problem first. And that's negative 6 times negative 9. Negative 6 times negative 9, that's going to give me a positive 54. If I bring down the rest, make that positive sign show up, I have this. Now, I go here. Remember, the division will come first. 54 divided by the 27. 54 divided by 27. That's going to give me a positive 2. Bring down the rest. I have this. Now, negative 6 plus 2. That's going to give me negative 4. Subtract. Keep the sign of the larger digit. Negative 4. Shall we keep it going? Of course we can. Let's try some more. All right, starting with this sheet. Here we go. All right, let's look at parentheses. I see the big parentheses set. You got 2 sets of parentheses in this one. You have this one, and you have this one. Let's start with the big one. All right, so what am I going to do first inside that parentheses? I hope you're saying that exponent. There it is. So I have 4 times 4. That one's going to give me 16. I bring everything else down. I have this. Okay. So where do I go from here? Adding or subtract, whatever I see first. And I see this. So I have my 16 minus 7, that gives me 9, right? Plus a negative 9. Guess what? Inside that parentheses, I have 0. But don't forget, the rest of that still needs to come down. All that needs to come down, right? So I'm going to put that 3 stays right there, here. And do that first. 2 times 8, that's going to give me 16. So this is where I am now. Now you know 0 times 0 times 0, that's going to give me 0. Divided by my 16, guess what? That's not going to work out. My answer here, 0. Oh my Lord. Remember we did this one in class? But yeah, we can do it again on video. Sure. All right. We got multiple sets here. Now, again, the hardest part sometimes is identifying where your parentheses sets are. So I'm looking hard. I see I have a set here. I see I have a set here. And then I see I have a set here. Let's first start with the pink set. You're going to see this. This is 2 times 2. 2 times 2, 4. Bring down that subtraction sign. I bring the rest, and I have this. Now, negative 2 minus 4, remembering our integer rules, that is going to give you a negative 6. Okay? Notice I didn't write it out. Let me do it over here, just in case, so you can see where I am. Negative 2 minus 4. How did I get negative 6? Step 1, step 2, step 3. Negative 6. So again, all about memorizing those integer rules, right? And I see my multiplication is in between this one. I'm going to go ahead and do what's inside this parentheses. I have negative 3 plus negative 5. Integer rules, negative plus negative. Add, keep it negative. Negative 3 plus 5, 5, 6, 7, 8. That's going to give me a negative 8. Remember that multiplication is right there. Going to the, bringing down that division, going to the last parentheses set, negative 9 plus 6. Add negative 9 plus 6. I'm going to subtract. Keep the sign of the larger digit. That's going to give me a negative 3. So this is where I am. Did what's inside the parentheses here, here, and here, and then brought down the symbols that was in between. So where do I go from here? Multiply or divide whatever I see first. That means I'm going to do negative 6 times negative 8. Negative 6 times negative 8 is going to give me a positive 48. Remembering and practicing your integer rules. Divided by that negative 3. That is going to give me a negative 16. So again, you can see the importance of making sure you understand your integer rules, especially when we proceed into these order of operations, and the more complicated that they will get. Integer rules are important. Again, these are skills you should be able to do by hand, so please make sure you get that practice in with those integer rules. Practice, practice, practice these integer rules, right? And if you need practice of just integer rules without having to put order of operations in it, without having to put decimals in it, without having to put anything else in it, go back to the Google Classroom and take a look at the video that's under 913, 2022, integer practice. You see your sheet with the rules, and you see different sheets of integers, adding, subtracting, multiplying, and dividing them, all sheets of them, and a video that goes along with it. Get that integer practice in for you. So again, when you're doing these, it becomes a lot easier. Knowing those rules, and the less mistakes you'll make, knowing those integer rules. Let's keep it going. Here we go. All right, look at this super long one that we have right here. I'm identifying my parentheses set. Now I see a parentheses here, and I see one that's ending here. Oh, and take a look at that. If you look even closer, you see here and here. Look at that. So this means I'm going to start with the inner set, or we call them nested parentheses. Sometimes you'll call them inner parentheses, or you call them nested parentheses, right? My nested parentheses says I start with this first. Negative 7 minus negative 8. Look at the shortcut. So really I have just negative 7 plus 8. That is going to give me a positive 1. But now I'm within the blue part of the parentheses and I have this, right? So I have 10 divided by 1. 10 divided by 1, you can see that's going to give me a positive 10. I'm going to go ahead and bring down the rest. Negative 10 plus 8 squared plus negative 5. Where would I go from here? I'm hoping you said this exponent. If I work with the exponent, I then have 8 times 8. That gives me 16. I'm going to bring down the rest. That's positive 16. Here we go. Now where do I go? Multiply or divide whatever I see first. I see a multiplication first, which means I see this. 10 times a negative 10. That's a negative 100. Bring down your rest. Where am I going from here? Where I go from here, again, add or subtract whatever we see first. And if I'm going left to right, I see this addition problem first. 100 plus negative 100 plus a positive 16. Subtract, keep the sign of the larger digit. That's going to give me negative 36. I bring down my rest. I have negative 5. Look at our integer rules. I have a negative plus a negative. What do we do when we have a negative plus negative? We add them. 36 plus 5 is 41. Keeping it negative. So final answer here, negative 41. Now again, don't forget to practicing on your own, whichever. Most of the sheets I provide in the Google Classroom also has the answer keys attached. Look at that, negative 41. All right, keeping up the practice. Here we go. All right, so here we go. Take a look at this one. First, identify where our parentheses set. I see I have a parentheses ending here. Where does it begin? Here. Which means I have another parentheses ending here. Therefore, it must begin here. There we go. And you have a parentheses set that's right here too. Let's see what we got. First through this, negative 9 plus 9, that is 0. And then that brings me to the picked side of the parentheses, and I have 0 times 3. 0 times 3, 0. I'm going to bring down my division sign. I'm going to complete this. 8 minus 5, that's going to give me 3. Bringing down everything else. I'm here. So where do I go next? That exponent. I have 3 times 3. We know that that's going to give me 9. Oh, sorry. The exponent wasn't a 3. It was a 2. Rather, it was a 3. There we go. So 3 times 3 times 3. 27. Bring down everything else. Where do I go from here? No, that's 0. Bring down the rest. 0. All of that work to get an answer of 0. I know, right? Going over here to the next one. Okay. First, identifying some parentheses sets. I see this one. I see this one. I see those two. Let's start with the first one. 6 plus negative 5. That's going to give me a positive 1. 8 minus 7. That's going to give me a positive 1. Bringing down the rest. All right. Where am I going to go from here? Going to the exponent. Got to do the exponent first. So if I do the exponent first, that's negative 9 times negative 9 is going to give me a positive 81. There we go. And now where do I go? I hope you see that multiplication. Ah, sorry, not multiplication. Look at that. It's division first. I was going here, but then I realized here, huh? 1. Now I can go here. I have -3 plus 81. Integer rule, subtract, keep the sign of the larger digit. 78. Last one on this page. All right. This will match this. Then I see this. Look at that. All right. Start in the green. Okay, I only have adding or subtracting in the green, so I'm going to start from what I see first, which is subtraction. That 10 minus 2, right? That's going to give me 8 plus a -8, right? That's going to give me 0. This now puts me where the blue is. With the blue, don't forget that 3 is still there. And then I have this. Okay? So this is where I am now, in the blue part of the parentheses, right? What am I going to do first? Of course, I'm going to do the exponent first. 0 to the 3rd power, still going to give me 0. Bringing down everything else. This is where I am. -6 times 0. Guess what? 0. Don't forget, now that you're outside of the parentheses, bring that down. Where would you go here? 8 times 8, 64. You're still dividing it by 0. Once again, all that work to get an answer of 0. There it is. And let's keep it going. So we got even harder. So with these, when we had practiced them, I didn't practice this sheet in class. I think I went straight for the other sheet, maybe. No, I did go for this sheet. And I remember with this one gave us a very large number, and I said it was okay to do with the calculator, right? But for the ones I'm going to practice on this video, I'm going to do ones that we'll do without the calculator. So let's see. So I'm going to go over to number 2. Because I do want you to practice these. Remember, again, without a calculator. Skipping over to number 1 because it gave us a, 64,000 something. And it was a large problem to do without the calculator. So we'll try to get some smaller numbers here just so you can get that practice without the calculator. Because again, it's all about reinforcing the integer rules. All right, here we go. So remember with these, oh yeah. And we first got nervous about these brackets, right? These brackets mean same thing as the parentheses. And so do these thingies. Now, I forgot what the official name of these are, but I can't remember. But guess what? They work the same way as parentheses. So all of it are parentheses. So knowing that, you know that we are going to start here. So if I start here, you see this is 4 times 4 times 4 is where I'm going to go first. So that means I'm going to take it here. My 4 times another 4, right? So I have 4 times 4. Now we know which that one is. The 4 times 4, that's going to give us 16. And then I'm going to take that and multiply it with another 4. And that's going to give us 64. That should give us 64 altogether. Now again, no calculator with that. So you should have been able to do that. 6 times 4, 24. 1 times 4 is 4, plus 2, 6, 64. All that by hand, people, by hand. So now I know 4 times 4 times 4 is 64. Minus the 4, that gives me 60. But remember, I am now on the pink side of the parentheses, and I see this bringing it back down. So I have 11 minus 60. Again, integer subtraction rule. 11 minus 60. Step 1. Step 2. Now we subtract, keep the sign of the larger digit. So I have 60 minus the 11. That's going to give me 489. If you weren't sure, doing it by hand, 60 minus your 11. 49. Keep the sign of the larger digit, and that happens to be the negative, so negative 49. That's what I have so far, negative 49. Now let's not forget, got to bring that down, so negative 49 times a positive 3. That's where I am now. Negative 49 times positive 3. Let's do it by hand. 49 times 3. 9 times 3, 27. 4 times 3 is 12, plus 2, 12, 13, 14. That is 147, but don't forget your integer rules. A negative times a positive. Answer is negative. So my complete answer for this one, negative 147. Let's keep it going. Let's take a look at here. All right. So again, not being scared of the brackets, they mean parentheses. And so do these. So this is where we start. 5 minus 2, 3. That puts us outside to the pink. Bring down my 10 times that 3, that gives me 30. And now I bring down everything from outside. I have 5 squared. We go to the exponent first. I have 5 times 5, 25. Bring down the rest. I have 25 minus 30. Follow your integer rules. 25 minus 30. Remember, step 1, step 2. Step 3, follow your addition rules. Positive plus negative. Subtract. Keep the sign of the larger digit. Negative. Number 3, we have negative 5. All right. Number 4. Where do we start? I see this, and then we see this. That's where we're going to start. Negative 48 divided by 4. So, I'm doing this, right? 4 will go into itself 1 time. 4 goes into 8 2 times. So, I know that this, worked it out by hand, the answer is 12. Negative 48 divided by 4 is 12. But putting the integer rule to it, negative 48 divided by 4, that's negative 12, because negative divided by positive, negative. I bring down what's rest. That plus sign still comes down. So what I have is 3 plus negative 12. I can put the parentheses around here to make it look nicer for you. There you go. So if I have 3 plus negative 12, what do? That's right. Subtract, keep the sign of the larger digit. So in this case, all that will going to be a negative 9. That covers all the parentheses. Bring down the rest. Where we go from here, that exponent, negative 4 times negative 4 times negative 4, negative 4 times negative 4, that gives us positive 16, times another negative 4, we get negative 64. So I have negative 64 here. And then, don't forget, we're going to bring down the rest. Which was the times negative 9. Make it look easier. I have negative 9 times negative 64. Multiplying this by hand. Remember, let's do that over here. First, I know my answer. Whatever my answer is going to be positive, because I have a negative times a negative. Your answer will be positive. So if I do my scrap work, 64, I'll write it this way, times 9. 9 times 4, 36. 9 times 6 is 54 plus 3, 54, 55, 56, 57. So my answer, positive 576. Ooh, let's take a look at number 5. Here we go. I'm here. Okay. And I see the other set here. Now, I have negative 78 divided by negative 13. So negative 78 divided by negative 13. And doing this by hand, I hope you come up with what I did, and that would be 6. 13 will fit into 78 6 times. And I have a negative divided by a negative. So the answer is a positive 6. I'm going to bring down what's left, which is the inside the orange part. I have plus negative 8, right? So plus 8 plus, negative 8 plus 6, that gives me a negative 2. You've completed all that. Bring down the rest, times 2 cubed. We go here, don't we? 2 times 2 times 2, right? So my 2 times 2 times 2, we remember that's going to give us 8. Bring everything else back down. Now I have negative 2 times 8. That will give us a final answer of negative 16. Let's do number 8. Number 8. Let's separate first. See that? And I see that. There we go. So I'm going to start here. I have negative 5 times negative 5 times negative 5. So my negative 5 times negative 5 times negative 5, that gives me, do it inside, negative 125. Negative 125. Bring down the rest of what I have so far, plus negative 2. All right, negative 125 plus negative 2, integer rules, that's going to be negative 127. Now I bring down what's on the pink side, times negative 5. Ooh, look at this. Negative 127 times negative 5. So again, practicing your multiplication by hand. Negative 127, I'll multiply that with negative 5, I should get 635. It's going to be positive, 635. Let me do that one by hand, just in case we need that practice, right? First, I know my answer is going to be positive because a negative times a negative is positive. So I just multiply these two numbers together. This is what it looked like when I did it by hand, right? 7 times 5, that's 35. 2 times 5 is 10, plus 3 gives me 13. 5 times 1 is 5, plus 1 gives me 6. 635. Doing that by hand. Please brush up on those skills. All right. Now don't forget, I have the rest of this to bring down. That all still needs to come down. So minus negative 10. So what I have now is 635 minus negative 10. Do you see what I see? Do you see what I see? Look at that. I see my shortcut. I see my hack. So now I can just look at it as 635 plus 10. That's going to give me 645 for the final answer. Okay. Let's do again. Looking at number 12. All right. So if I look at number 12, watch this. And then I have this. Let's work inside here first. That's negative 2 minus negative 10. Negative 2 minus negative 10. Hopefully you see the hack of the subtraction rule. I have this. So now I can see it as negative 2 plus 10. I subtract, keep the sign of the larger digit. I'm going to have a positive 8. That now brings me to what's inside the orange. It's this. So now I have negative 2 times that 8. That's going to give me a negative 16. That takes care of the parentheses, but I still have to bring down this part. That minus sign is still there. So now we're here. Sorry for the bad handwriting, right? We have to do this first. Negative 2 times negative 2 times negative 2. That's going to give us, remember, a negative 8. So what I have is, I'm trying to squeeze into here, negative 8 minus negative 16. Again, make it more comfortable for yourself. Put a parentheses around here if you need to. And there we go, right? You see that shortcut? Came back. So now I have negative 8 plus 16. Don't forget your integer rules, right? You're going to subtract, keep the sign of the larger digit. If I do that, My answer is going to be a positive 8. Negative 8 plus 16, answer positive 8. All right, let's take a look at what's next. What next I had, more of the same, order of the operations. They're just a little bit extra, giving you more practice of what we just did here, okay? The big difference is the ending. So you have all the stuff that's in the brackets, and then you have something small on the outside of the brackets. This page right here, same thing. You have brackets, all the stuff that's here, and then you had a couple of things on the outside of the brackets. See? A couple of things on the outside of the brackets. A couple of things on the outside of the brackets. So it's just adding on a little bit instead of just one thing outside of the bracket. For this next sheet, you have a couple of things outside the bracket. So let's take a look. Shall we try a couple of these at least? Why not, right? I know you guys are down with it. All right. We will take a look at this first one that we have. We'll do that one. Okay. Bracket. And I have here, which means I'm taking a look at here first. Negative 3 times negative 3 times negative 3. That will give you negative 27, right? Plus 8. Remember your integer rules, positive plus negative. You're going to subtract. Keep the sign of the higher digit. Negative, so I have negative 27 plus 8. Find a difference between the two. That will be 19. Keeping the sign of the higher digit gives me negative 19. Now I'm in the red. So now I'm going to do times that negative 3. Okay. Negative 19 times negative 3. Let's do that one on the side. Negative 19. Well, I know my answer is going to be positive because a negative times a negative is positive. So let me just look at it as 19 times 3, right? 9 times 3, 27. 1 times 3 is 3 plus 2. That gives me 57. So all this gives me a positive 57. Now I'm outside. Now I'm outside of the bracket. So that means I'm going to bring down the rest. The rest that I see is this negative or minus 2 plus negative 8. We have adding or subtracting, so you know I'm going to start here. Adding or subtracting whatever we see first. So I have 57 minus 2. My 57 minus 2, what is that going to give us? Of course, that's going to give us a regular 55, doing your integer rules, right? Now, you can see this as regular 55, or you did this on your side paper if you needed to. It's a regular subtraction problem, but it still follows those integer rules. Step 1, step 2. Step 3, follow my addition rules. Subtract 57. Difference between 57 and 2 is 55. Keep the sign of the larger digit. The 57 is higher, so I remain at 55. So again, it does look like a regular, just plain old numbers, 57 minus 2, correct, which is 55. And still following the integer rule way, you will get the same answer. So I always say, look at everything as if they're integers. There we go. So now that I have the 57 minus 2, 55, bring down my rest, which was a plus a negative 8. So remember your integer rules. You're going to subtract, keep the sign of the larger number, and this time 55 minus 8, 47. I'm going to have a positive 47. So that was everything that was in the parentheses. Everything that was in the parentheses. And then leaving us with the final answer of this part to a positive 47 for that first one. There it is. We'll do a few. All right. We'll do a few more. Let's see. Now, of course, if you're doing your order of operations at this level, right, you should be fine on the GED test if it gives you a plain order of operation question, right? Because this is above and beyond. I see my parenthesis set right here, right? And I see the other right here. I will do this first. 2 times 2 times 2, which we know is 8. My screen is messing up. Hold on a second. Let me try that again. So I'm going to mess up a little bit. Start here. 2 times 2 times 2, 8. Bring the rest down. I have minus 4. That gives me 4. Bring down what was inside the pink. Notice I have 4 minus 4 now. That gives me 0. Sorry, my pen is messing up a little bit for this problem, but I'm going to keep it going. That takes care of all the parentheses, the brackets, etc. Bring down the rest. Times 2 minus 11, right? You do what's in the parentheses first. So 2 minus the 11. Don't forget your integer rules. So 2 minus 11. That gives me my negative 9. I bring down the rest. Times 0. 0 times negative 9. Answer 0. All right. So let's see. Well, this video is way past an hour. So there's some extra practice. Of course, all these have the answer keys attached. And I know I said I was going to get to some of these on this video. Sorry about the glitch. So this is what I'm going to do. Meaning the video is way past an hour, but I know you're anxious and you really, really, really want to try some of these. So I will do a couple of them, and we'll explore more of them in class next week. I know, probably for those of you that waited all the way to the end of this video to try to attempt some of these extra hard ones, here we go. Now I did grab these from a GED book. So we're going to practice this one. Let's take that one first. In fact, you know what I'm going to do? I'm going to put it on a plain sheet of paper because it's going to take some work, isn't it? All right, give me a second. Let me pull up a plain sheet of paper. Here we go. All right, I'm going to rewrite that problem. That problem was 25, 4 plus 1 times 3 plus 6 minus 1. Let me double check. 25 divided by 4 plus 1 times 3 plus 6 minus 1. There we go. All right, so we follow PEMDAS just like we normally do. I do have some things in parentheses, so take care of those first, which means I'm going to take care of this. I have 4 plus 1, that gives me 5, right? 6 minus 1, that gives me 5. So if I rewrite it, I now have this, 25 over 5 times 3 plus 5. See where I am here? There's your parentheses. We don't have exponents. We're going to multiply or divide whatever we see first. Well, remember what I said about fractions? Fractions mean division. So that is 25 divided by 5. Basically, when we look at fractions as division, it's this. Bottom number outside of the house, top number inside of the house. You know that 5, we're going to 25 5 times. So that's what this is going to equal. This will give me 5. If I bring down the rest, I now have this. Now you can do that multiplication problem. 5 times 3, 15, right? Bring down the rest, I have 15 plus 5. That will give me 20. Not too bad so far, right? Let's go ahead and put another one on here and make this video super long. All right, so, what was I? Right here. Where should we go next? Okay, all right. What? What's that? What'd you say? You know what? Let's go down and try one of these first. I'll come back to the other ones. Let's just go ahead and try this one first. Get a little variation of all of them. Let me rewrite that one over here. So this time I have 19 times 5 minus 8 minus 7 plus 4 divided by 10. Now, PEMDAS, right? Now, I know what you're thinking. The rules of PEMDAS says I'm going to do what's in parentheses first. Okay, so let's do this. We're going to do this part first, right? Let me put that down here. So that means I have my 8 minus 7 plus 4. You know that's going to give you 1 plus 4. That gives you 5. So if I rewrite this, I've now shortened it to 19 times 5 minus 5. Because all of that gave me 5. 8 minus 7, that gives me 1. And then 1 plus 4 gives me the 5. We put the bottom back down. Divide by 10. So this is where we are now, right? Parentheses, done. There's no exponents. We multiply or divide whatever we see first. You know what? Technically, it's a fraction. So we technically see division first, don't we? But before we can actually do the division part, we want to get the top number and the bottom number as small as possible. So that means you're just going to work out the entire top, work out the entire bottom if you need to, then divide. Okay? So that means I'm going to solve the top half first before you can do the division. You have to solve the top half first. So I see this as 19 times 5. So if I do my 19 times 5, that's going to give me 95. Bring the rest, I have 95 minus 5, right? That gives me 90, doesn't it? So that top half equals 90. So now I look like this. Now, doesn't that make it easier to divide? I hope you're saying yes, it does, because I agree along with you. Because now we just have 90 divided by 10. 10 will go into 90 10 times, leaving me my final answer as 10. All right. So now let's take a look at, where should we go now? We're gonna do these harder ones. Let's take a look at this one next. Let's take a look at that one. And bring that back over to my paper. Let's see if we can do this. I have 2 minus 14 minus 5 divided by 9 plus 6. Okay. What do we have going on here? We have our PEMDAS order. And PEMDAS questions that look like these, the not so normal ones, tend to go out of PEMDAS order a little bit. And that's because, remember, when you do the division, you're going to have to figure out what's on the top first and then the bottom before you can actually do the division part. So meaning this, where am I going to start here? I don't have anything in parentheses. I don't have any exponents. So I'm going to multiply or divide, right? Now I see this as the multiplying or divide part. That's a multiplication problem. But before I can get to the division part of it, I have to reduce that, make that smaller first. So I have 14 minus 5. So if I get my 14 minus 5, that's 9, right? So really that fraction looks like this. Now I can do my division. 9 will go into 9 one time. Now I can bring down what was left. So I have this. So if I do this, we see this as 2 minus 1 gives you 1, plus your 6. You see our final answer here will be 7. So remember, you want to get rid of everything that's on the top and anything that's on the bottom if you have to before you do your division when it comes to the fractions that look like these. Let's go ahead and take a look at another. Okay, so we take a look at another. This time, might as well go straight in a row. Let me go ahead and do this one. I'll bring that one over. 14 divided by 2 times 15 divided by 10 minus 7. Okay, let me make sure I wrote that down right. Is that where I am? Yep, 14 over 2 times 15 divided by 10 minus 7. All right, so again, PEMDAS, right? We don't have any parentheses. We don't have any exponents. We know we should be multiplying or dividing whatever we see first. Now, here's the thing. I see a division, right? I see the multiplication. We're going to multiply or divide whatever we see first. So the first thing I'm going to do is reduce these fractions, all right? So I'm going to take this one. Now that's 14 divided by 2, right? 14 divided by 2, that should give us 8, 8, 9, 10, 11, 12, 13, 14, 7, excuse me, I said 8. So that's 7. Now, before I can divide with this fraction, I have to do the subtraction first. 10 minus 7, that's 3, right? So that's really 3 on the bottom. And I'll put my 15 back on top. Where do I go from here? Well, before I see a multiplication problem, but before I can multiply, I have to reduce this fraction. So see how it breaks the rules a little bit? 3 will go into 15 5 times. Now I'm going to bring that 7 back down. So what I have is 7 times 5, giving my answer of 35. So really it's all about getting rid of all the funkiness of those fractions, right? And I mean by funkiness is like all the stuff that's on the top, all the stuff that's on the bottom, all the stuff that's on the top, all the stuff that's on the bottom, and then you can reduce the fractions or multiply or whatever it says to do next. Okay, so promise a few more. I will go with, all right, I see what you're looking at. Let's do this. You want to do that? Let's do that. Let's give it a shot. If I rewrite it over here, all right, so I have 3 cubed divided by 5 minus 2. Subtract that. 4 minus 2 squared divided by 2. Now again, first thing I'm going to do is reduce everything I possibly can with these fractions. So I'm going to start with the first one. I'm going to start here. 3 times 3 times 3. We see that, right? So I have 3 times 3 times 3. That's going to give me the 27. So that top is 27. I'm going to reduce the bottom. 5 minus 2. Guess what? That's 3, right? And then, if I go here, 4 minus 2, that's going to give me 2, right? And then I'm going to take that 2, square it. 2 times 2, that's 4. So with the refractions completely reduced, this is what I have, right? So this is where we are now. Now, you're going to have to remember, multiply or divide, whatever we see first. We got to do the division first. Do the division first. Do this division. Whoops. Right? 27 divided by 3. How many times is 3 going to fit into 27? 9. Bring down my minus. How many times will 2 fit into 4? 2. So simply, I just have 9 minus 2. With my 9 minus 2, guess what? Answer 7. So hopefully you're picking up on a pattern of those. Yep. I hear you. Hey, let's do another. Gotcha. All right. So where am I going to go now? Let's go with all right. We'll do it. Here we go. Let me rewrite that over here. Man, whose idea was it to put these up here? I have 2. Hardest part is trying to keep this neat. 17 minus 11 squared times 15 minus 5 divided by 2. There we go. All right. Okay. So, not so pretty, but here's what we got. You know you're going to start inside the bracket, right? And I can do my parentheses that are inside the bracket. So let me start here. I have 17 minus 11. So I'm 17 minus 11. That gives us a 6. So I see this as 6 squared, right? And now, if I do this parentheses, 15 minus 5, that gives me 10. So if I rewrite it, I now have this. 2, 6 squared times 10 over 2. Where am I going to go here? Well, according to PEMDAS, I would do exponents. So I'm going to have here. That's 36. So now I have 36 times 10 over 2. Where am I going to go from there? Right? Now I know I need to multiply 36 times 10 over 2, but guess what? Reduce that. 2 will go into 10 5 times. So now it really looks like this. Now I will do this. 36 times the 5. 36 times the 5. That gives me 180. Right? And then you have your 2. That means multiply 2 times the 180 that's inside the brackets. That's going to give me 360. That was fun, wasn't it? All right. So, Okay, I'm going to do that last one that looks like it's complicated. If we do this one together, the rest of these up here should be cake, right? So let's just go ahead and tackle that one. We'll go ahead and rewrite it. Where was I? 150 minus 4, bracket, 3 plus 9, 4 minus 1, times 14 minus 11 squared. Here we go. I'm going to start with the parentheses. 14 minus 11, that gives me 3, right? So that means so far I have my 3, and that's 3 squared. If I bring down everything else, I'm here. 4 minus 1, right? And this is where I am with the bracket. Don't worry, we're going to bring down the 150 minus 4 in a minute, okay? Where do I go from here? According to PEMDAS, I do this. 3 times 3, that's 9. So now that gives me here. Right? I'm going to need to reduce this fraction before I can multiply it with the 9. So if I put the numerator together, that gives me 12. 9, 10, 11, 12. 4 minus 1, that's 3. So now I can look at it like this, right? That I can reduce. 3 goes into 12 4 times, right? The 4 times 9, or 9 times 4, 4 times 9. That gives me 36, right? So what I've just done is I've taken all of that and I got 36. But don't forget, this part still needs to come down, 150 minus 4. So I had 150 minus 4, and that 36, remember, was in the bracket. So where I go next is I'm going to multiply these two. Now I'm running out of space, so I'm going to rewrite it like, let me make some space and rewrite it. Okay. So what we just said was all of that we know now is giving us 36, right? Outside of the bracket. This is where we left off before I erase. Now, I have 140 or 150 minus 4 times 36. Remember, the brackets mean multiplication, just like we were doing with the regular order of operation. So that means I'm going to multiply these two first. I have my 4 times 36. That's going to give me 144. 4 times 36, maybe sure, 4 times 36, 144. I bring down my 150. So now I simply have 150 minus 144. My final answer here, 6. All of that just to get the number 6. Okay, so this is definitely where I'm going to leave it for today on this video. So next week when I see you in class, yep, we're going to do a few more of these. These are a little bit more like, you would commonly see on the test. These were just the super, super hard ones, but I hope you had fun doing it. Okay, guys, calling it an end. And I'll see you on the next video where we talk about fractions. And then next week, I'll see you in class to do some more of these and continue with the fractions wherever we left off. See you then.